I'm excited to talk about productionizing GenAI models. To state the obvious, I'm sure you're all feeling this, democratization of AI is here. For decades, we wondered what it would look like, and it's here. Any developer can add AI capabilities with very, very little effort, and that's super exciting. And this is clearly the moment where GenAI moves into production. I keep asking this question, and I keep watching the ratio go up. How many folks actually have something in their company using a GenAI tool in production? All right, all right. Less than Google Next. So interesting. This is a snowflake of a different crowd here, maybe. So let's talk about what I care about, which is making AI in production. And the biggest problem that I think we all see, which is that it's incredibly easy to make an awesome AI demo, and it's so much harder than you would think to get that in production. I think executives at every company are frustrated about this right now. I think every developer is frustrated by this. In software development, we talk about the first 90%, the second 90%, and the third 90% of development, right? That's in software. But I feel like in AI, there's like the first 90%, second 90%, maybe like 8 or 9 more 90%, and maybe you never actually get it out into production. And my whole career, what I've been really passionate about is getting those things from demo into production. And now with GenAI, there's so much more opportunity to do that. And I think this fundamentally comes from the fact that there's a big developer tools gap in AI and what you might call GenAI ops now. Like there's a software development workflow, incredible number of amazing tools that help software get into production. In AI development, or as Andrea Karpathy called it, software 2.0, you just see all ad hoc solutions everywhere. You don't see awesome tools like you have in the software development workflow. And so we work on some of them. And I want to say, at Weights and Biases, we think of our audience as breaking into 3 different types. So first of all, you have the foundation model builders. Those are people that are actually building the core LLMs in production. Snowflake, obviously one of them. You have the ML engineers that are building models or fine-tuning models inside of their companies. And then you have this new group of software developers that are trying to get Gen AI models into production. And our mission here at Weights and Biases is to serve all 3, although each of these personas is slightly different. We're passionate about all 3, even though the size, we should acknowledge, of each group is quite different. We think there's thousands of foundation model builders, maybe hundreds of thousands of ML engineers, and maybe tens of millions of software developers. One thing that I'm super proud of, just to say it, is that nearly all the foundation model builders are using Weights and Biases. So GPT was built using Weights and Biases. Snowflake Arctic, which recently came out, was built using Weights and Biases. And actually, Arctic was incredibly open in their production. So you can go in and see a lot of the Weights and Biases charts and graphs that actually went into that workflow. But also Llama 3, Mistral, almost any foundation model that you would have used was built using Weights and Biases toolset. But of course, this is a small, small fraction of our user base and our customer base. The biggest section of our customer base historically have been people building models. And I think what's super exciting about that is that model builders now span across basically every industry. There is not a Fortune 500 company today that's not interested in building their own models. And what do they get out of Weights and Biases? Why do they need different tools for the model development process? I fundamentally believe that it's because software development is this linear process. When you write code, you're typically gradually adding features, you're gradually adding code, hopefully you're removing some old code, but mostly you're adding functionality step by step. Your workflow is writing code. When you are doing AI development, Gen AI, building your own LLM, almost all the things that you do are experimental. Almost all the things you try don't see the light of day. And this might look the same to an executive, but it is a fundamentally different workflow. Because when you develop software, the code is really your IP, right? And you take this really seriously. No company would let their code not be saved in version control somewhere, at least in the last 30 years. But when you do AI development, your code isn't your IP because your code is only a small fraction of what you're building. What you're building when you're developing AI is actually learnings. It's all the things that you try, all the prompts that you do that don't actually work, all the hyperparameters that you try that don't actually work. And so when learning is your IP, reproducibility really, really matters, right? Because you want to be able to go back and look at what happened. And you can't do that if your work isn't reproducible. But reproducible is incredibly hard, right? You see in almost every field in academia a reproducibility crisis. Everyone wants reproducibility, but nobody wants to put in the work to write down exactly what they're doing at every single step so you actually have true reproducibility. And so one of the core things that Weights and Biases tries to get our customers to do is track everything. Not by harassing our customers to do it, but by making it really easy to get that reproducibility in the background. And I get really excited about tracking everything because when you track everything, you can collaborate better. And when you collaborate better, you can move at a much higher velocity. Every step gets easier, and you get from demo into production much, much faster. And so I'm here at the Builders Hub, and I think like most technical CEOs, I really want to tell you that I'm still a builder. And so rather than taking you through one of our customers' GenAI use cases, I wanted to walk you through a use case that I really did, that I called Autobot. So it's a little bit of a toy use case, but it actually matched so many issues that our customers run into. And this came from my daughter. My daughter loves Alexa. She has a relationship with Alexa, and she talks to Alexa all the time. And she asked Alexa a couple months ago, play my favorite song. And if you know my daughter, her favorite song is not hard to discern. You don't need AI to figure out my daughter's favorite song. Her favorite song is Baby Shark. She plays it constantly, right? Alexa has the data to do this. I think for actually privacy reasons, they don't use the data, but she was actually heartbroken when Alexa did not play her favorite song. And she's basically like, Alexa doesn't know me. And I thought, we could do better here. I could build an Alexa with the LLM tooling out there. And I looked at, okay, what's out there? There's something called Mycroft, which is kind of an open source Alexa, but didn't really use the latest LLM tools. And my friend down the street actually was showing me that he could run Llama 2 on a Rock Pi, which is a slightly souped up version of a Raspberry Pi. You can buy it for $200. This was 6 months ago, so maybe they've come down to $150, but that's starting to get in the range of the price of an Alexa. So I thought, maybe I could build my own Alexa that doesn't talk to the internet. I wonder if I could do that. And so, I made a bunch of skills, right, to kind of match Alexa. So I have a little math skill, a little weather skill. You can actually build these skills really easily, right? So if you know someone's asking for the weather in Boston, you can make a little app that gets you the weather in Boston. If you know somebody's asking for the news, you can make a little, 5-line piece of code that queries an API for the news. The trick is actually understanding with human input, what are they asking for? So my architecture here, I used OpenAI Whisper, open source model, to synthesize the speech. This works super well. So my daughter asked, what's the weather in Boston? And it gets that. But then how do you go from what's the weather in Boston to code, right? And here I wanted to say weather, then in parentheses location equals Boston to run my little Python script. So there's an amazing open source stack available now. I mean, this is just one way to do it, but I used Llama and Whisper. That's the real hard work here, and it's really, really impressive and getting better all the time. Llama CPP, an incredible library where for free you can run Llama 2, Llama 3 on your MacBook. You can even run on this $200 device. It's really incredible. And I would also say that Whisper is getting better all the time, and it works super well. But now latency matters a lot here. So I can't use the biggest models. I don't have time to call out to OpenAI. I need to run this on the local machine just to make it fast enough. Because I not only have to transcribe the speech, I also have to translate it into a function call. And Llama doesn't work with a default prompt. So I fed this into Llama 2. This is a few months ago. And I asked, okay, what's the weather in Boston? Answer my question. I got 0% accuracy. It didn't even format the answer in the way that I wanted it to. So I thought, okay, I'm a smart guy. I can do some prompt engineering. So I tell it what functions it has. I kind of mess with it for a while. And honestly, still 0% accuracy. It still isn't even formatting it in the way that I wanted it to. So I switched over to Llama 2 chat, slight variant on the Llama 2 model. And you know what? It worked a little bit better. It started to get 11% of the time I got the function call right. So in this case, it says function call weather location equals Boston. All right. 11%, still not that good, but better than 0%. So I started incorporating feedback from the model. I started just kind of iterating with the model, seeing where I got it wrong, giving it feedback, making the prompt longer and longer, and I got it to 75% accuracy. Really satisfying afternoon. Weights and Biases kind of tracks all this so I could share it with my colleagues. And then I thought, okay, I'll add some examples. It actually made the accuracy worse. I only include this because there's 100 things besides this that I tried that also made the accuracy worse. So I'm telling you this fun linear progress story, but I think the reality for anyone that's worked with LLMs is you keep going backwards, right? It's like 2 steps forward, 3 steps backwards, over and over and over. But I kept iterating, and and then Mistral came out, and there's a lot of fanfare. They were built on weights and biases. I thought, okay, I'll try the Mistral model here. And boom, out of the gate, it got me a 4% improvement. I'm from 75% to 79%. Really effortless. It's the same API. Also runs on my little $200 Rock Pi. But honestly, I gave it to my daughter at this point. Still incredibly annoying. 79% accuracy in a consumer device is enraging. I think you might have seen this with the Humane AI bad press. It was interesting to watch how we really expect our consumer devices to be at higher than 79% accuracy, because there's also some error coming from the transcribing. So I thought, okay, let's try some fine tuning. And fine tuning used to be really tough to do, especially these giant models, painful to fine tune. But actually, LoRa is a way to fine tune with a lot less compute, and it works almost as well. Now there's lots of services that will do it for you. I was excited. I could do QLoRa on this second generation old NVIDIA card that I had in my basement. Right, this runs on basically consumer hardware. And I was actually able to fine-tune a 7 billion parameter model. I feel like kids these days might not find that amazing, but I still really enjoyed it. I think like 2 or 3 years ago, this would have been absolutely impossible to do. But I needed a data set to fine-tune, and my last company was a labeling company, but that made me all the more not wanting to go to a third-party labeler. I thought, I'll just create some examples myself. So I started creating some examples of things that I might ask and answers. And then ask ChatGPT generate me some more examples, right? And so now I have a really easy way to get tons and tons of examples to feed into my system. I gave a little schema to format the answer in. And now once it has examples, it can generate even more examples. And these turned out to be really realistic, almost all good examples to feed into my system. And honestly, after I fine-tuned Mistral, I got up to 98% accuracy. So I went from 0% accuracy to 98% accuracy in about a week of work. This was an incredibly satisfying project. And the amazing thing was it actually worked out of the box in other languages. So my upstairs neighbor came down and tried French here, and it just completely worked, even though I didn't plan it. So the whisper system worked in French, and actually my my translation system worked reasonably well in French, enough to impress my upstairs neighbor and my daughter. So it was quite a win, and you can go to Lukas/Auto here to see the code and fork it and play with it if you want to. But I think the lessons learned on this specific project that I have are something my customers tell me all the time, right? Which is like there's not one silver bullet, but all of these techniques that you hear about, you don't want to ask, hey, should I use prompt engineering? Should I use RAG? Should I use fine tuning? Really, you should be trying all of these things and seeing if they work for you, right? This is an iterative process, and each thing that you do is likely to add some accuracy. And this all worked because I had a very clear evaluation set and I could measure my progress along the way. And most of the experiments didn't work. So I would say if your engineers can't tell you how much one of these techniques improves the system, then they don't have a good evaluation setup. So that leads me to evaluating AI models. And these are the questions that I get all the time. Every day I get these questions. What foundation model should I use? Should I use fine tuning? Should I use RAG? Millions of variants on this. And all these questions, I dodge all the questions, because actually none of these questions are as important as this question, which I would ask back to you, which is, do you have an evaluation framework? Because the answer to these questions completely depends on your use case. It also depends on the model that you're using, and these models are changing all the time. So if you have religion about whether fine-tuning is good or bad, that's crazy from my perspective. You're going to be wrong, right? Like fine-tuning used to be hard. Now it's easy. Maybe there'll be new models where it's less relevant. There'll be some new technique. You better be ready for the new techniques that are coming. And the other lesson that I learned is start with a lightweight prototype and get it working end to end. There's something about GenAI that makes executives crazy, and they work on these projects without getting them in front of customers. And I really do think that we're forgetting about basic product design over and over and over, even in internal LLM tools. Like, is this a useful thing for an end customer? You can answer that question pretty quickly. These apps are not hard to build. I mean, I could build this toy app in a weekend and try it on my daughter. I think almost all of these use cases, you can build a prototype quickly. And then finally, incorporating end user feedback in lots of different ways is super important. We have an internal tool where you can ask questions about our own internal wiki, and it's been really helpful to get internal user feedback. So here's my basic lessons. This is not rocket science, but this is something that I see our customers messing up all the time. Build an evaluation framework, lightweight prototype, end user feedback, and iterate. And I would just say, because I think evaluation is the most important one, and it's the one where weights and biases has the most to say about it, couple best practices. One is you want to use multiple evaluation sets, right? You want to have expensive gold standard sets, right, that you're sure they're perfect, right? You also typically want to have broader sets where you can get a broader scope of data. You often want to have LLMs themselves do this evaluation. You really should not be doing just one form of evaluation of your model if the quality of the model is important to you at all. And then trying to make sure these metrics correlate with the user experience. This is the other biggest point of failure, right? I mean, accuracy is definitely not what the end user cares about. But then I kind of hate to expound it all on evaluations, because the biggest failure with evaluations is that people don't actually do it. You'd be shocked. I think I see everybody nodding their heads as I talk about it, but actually most of the companies that we go into are really not taking evaluation seriously. You can check out wandb.me/weave, which will offer some tooling for evaluation. We make lots of things, but this is the thing that I really, really care about at Weights and Biases, because I think this is the biggest pain point right now in getting LLM applications from demo to production. And look, I hear that I get to answer some questions. So does anybody have any questions? Or we can go to Richard Socher, who's up next.
Did you try OpenAI models for your auto app?
Yeah, I did. So, again, it's like each time you switch to a different model, you get different levels of accuracy. The 4 version was similar to Mistral pre-fine tuning. So the post-fine tuning, actually, in this use case, Mistral plus fine tuning was better than GPT-4 and significantly better than GPT 3.5. But again, if I spent more time on the prompt tuning on that specific model, I maybe could have gotten it better. But I don't know, I was kind of excited to do something that could run on my local hardware. Like, I think we kind of got away from the kind of hacker culture that I think was really good for AI for a good long time. And so I was kind of excited to see, I don't know, I guess I'm excited to see cheap hardware working for LLMs these days. Yeah. Or yeah.
I had a question. How do you suggest? I think reproducibility and tracking them is good, but I guess most of users won't be training a model from scratch. So let's say for someone who's just using a model by default or just using it to fine tune it, how do you suggest to use this? Let's say I've tracked all of my previous runs, or while doing fine tuning I've tracked my accuracy. How do I use that to improve the model performance?
How do you use the tracking the accuracy to?
Yeah, if all I'm doing is either fine tuning or just using a model pre-trained model, how do I use this information to improve the performance if I'm not training a model from scratch?
Oh, totally. So how does evaluation help you improve the accuracy of the model? Is the question. Yeah, it's an important question. So tracking it the first time won't help you, and I think that's why people don't track it. The first time. I actually think you should be tracking every single LLM call, because you could even run a new version of a model on those exact same questions and actually walk through what the differences are. But I think that the reality is nobody does this once. I think people think they're going to do it once, but once something's in production, you're going to want to make it better. In fact, you may not have a choice, because some of the LLM providers will change the LLM out from under you, right? And so it's not that tracking it one time will make your application better. It's that it gives you a methodical way to improve things over time, and you're almost certainly going to be changing aspects of what you're doing. And the problem, so we talk to a lot of people that say, hey, I do testing by vibes, right? Which basically means not testing. It's actually kind of a good thing that they test by trying it. But the problem is when you're doing testing by vibes, you can kind of have a sense, is this model good or bad? Is it working or not? But you won't have a sense if the next version of your model is better than your current version. And if you can't figure that out, then you can't make incremental progress. Yeah.
Thanks, Lucas, for a talk. Amazing talk. And you mentioned in the LM era, your code is not your asset, but learning is. Can you expand that for a bit? Do you mean all the prompt that's not working, that's recorded somewhere, so when you're changing new models and you can just build on top? I'm a little bit confused. Thank you.
Sure. So yeah, so I think even like with my project that I showed you, right, this Autobot that I made, right? You could go to GitHub and you could find where it's at now, right? You could find my current prompt. You could find the fact that I'm using Mistral by default here. You could find the current data that I fine-tuned it on, right? But I actually don't think that that's what's interesting about, or that's not even the IP that was sort of generated in that process. I think the IP that I kind of generated was, you know what? Mistral seems a little bit better than Llama 2 for this use case. Fine-tuning helps a lot for this use case. Prompts that add examples for some reason do worse for this use case, but prompts that add a lot of clarity about exactly what I want do well for this use case. Like I think, in my view, if I was like building a company around this project, that would be the information I would think would be really valuable. That's also the information that if I was an engineer and I left the company, would walk out the door with me if I wasn't tracking that. So that's why I'm saying I actually think the code, there's some value to it, but it's a little bit opaque, right? Because unlike a lot of software projects, there's a lot of learning that's missing from the code because it's not incorporated in the end result that I think is more important maybe to track than the actual code that gets generated. Any more? Cut me off when I actually don't have a timer here that it's on 0, so I don't know how much time I've taken.
Oh. Am I next or? Okay.
All right.
Hi, Lucas.
Yeah.
Hey, so your daughter is going to age over time, right? And so you can evaluate the model how good it is at a certain point in time. That the use cases as they change, develop, the world changes, totally. And the data that you're evaluating across changes. How does weights and biases kind of like adapt to that and continuously monitor the performance over time as the use cases might change?
Well, okay, great question, Robert. Nice to see you. Not a plant, but again, we don't do the evaluation. We're relying on our customers to do the evaluation. But I do think, again, making it easy to save tons and tons of evaluation data is important, right? Like I think saving every time your LLM gets called lets you run all kinds of different analysis, right? And data drift is a real issue for LLMs. I think people are going to be surprised by, right? Like I think if you have something out in production, the kinds of questions that somebody's asking it will definitely change over time. And I don't think there's, I'm sure that there's not really industry best practices for monitoring that right now, because most of the people that have LLM in production right now aren't even monitoring the quality of it. But once you get the quality monitored, right, and once you see that the quality is going down, then you could definitely do a deeper analysis of, okay, why is the quality going down? And any AI application in production, the quality is going to naturally drop over time as the ways that people interact with it change.
Hi. You spoke on latency issues. So we are building an MVP right now that is an AI secretary, receptionist, basically. And the latency issue is the #1 problem that we're having. We're tapping into ChatGPT. My question is, do you think it would be more productive to build our own language model? I know some people in this area are actually building their own language model for their AI receptionist. Or do you think time, hopefully quickly, will improve these latency issues?
Okay, so the question is around latency issues. What's your company? Or what?
Beauty Desk AI.
Beauty Desk?
Yeah, I am looking for technical engineers for my startup. So if you're interested, come talk to me.
All right. Well, look, I mean, latency is obviously a huge issue, and there's a lot of places you can land on the latency quality trade-off. Would definitely not recommend building your own model, but there are lots of options out there, including, OpenAI has faster models and slower models. But if you go into the realm of open source, the smaller models are going to be faster. There's lots of tricks for running those even faster. A lot of engineers are really passionate about it, so I'm sure if an engineer joins you, they're going to love to drive down your latency. But there often is a latency quality trade-off that can be tricky. We good? Yeah? All right. Well, thank you very much.